Hello, algebra students. Mr. Lawrence here, and we're going to really quick review what we did the past couple days, graphing linear inequalities and absolute value functions. Here I actually have a system of linear inequalities. I'm going to graph them on the same graph because they're two equations together, right? First one, the y-intercept is what? 0, -3. Okay, right there. And then I rise a slope of 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1. Now it's an inequality, and it's not equal to. It does not say equal to, so that's when I have to use the broken line. Okay, like that. I'm going to extend it the other way. And I need an arrowhead on the end. And I'll make it blue so it matches. A little bit thinner, make it blue, and put an arrowhead on the end. Okay, now I have to shade. But to know where to shade, I got to use my test point, right? And I can use the origin because this does not go through it. So I'm going to plug 0 in for y and 0 in for x. When I do that, I'm going to get 0 is greater than 2 times 0 minus 3. I'm going to simplify the right-hand side, which is going to become 0. 0 minus 3, -3. 0 is greater than -3. Absolutely it is. And so I will be shading this side of the line. Oops, I should be using blue, excuse me. Get rid of that yellow there. Okay, and so I should be shading this side of my line. Like that. Okay. All right. So now I'm going to do the red equation. Now it's in standard form. And I think I'm going to go ahead and I'm going to go look for the x-intercept. And to get the x-intercept, I'm going to put 0 in for y into the equation. And when I do that, I'm going to get 3x minus 5 times 0 is greater than or equal to 6. 3x is going to be greater than or equal to 6. X is going to equal 2. Yeah, I really should be doing equals when I'm trying to find the intercept. So 2, 0 is the intercept right there. And now I'm going to find the slope because A is 3, B is -5, and C is 6. And the slope is the negative of A over B, which simplifies to 3/5. So I'm going to rise 1, 2, 3, and run 1, 2, 3, 4, 5. Maybe I'll go down 1, 2, 3, and back 1, 2, 3, 4, 5. Right there. Okay, now it's a solid line. How do I know it's solid? Because it's equal to, sorry about that. Okay, sorry, TV turned on me there. So I need a solid line. Just going to go through those points. And okay, my equation was red, so I'm going to make it red. Make it a little bit thinner and put an arrowhead on the other end. And then I'm actually going to shade in yellow, but I got to do my test point thing to know where to shade. So I'm going to plug the origin in here. Get 3 times 0 minus 5 times 0, and that's greater than 6. So 0 is greater than or equal to 6, which is not true, so I will not shade the origin side of the line. I'll shade the other side. And so that would be down here, right? Now watch what happens. Look at that, I'm getting some green. So the solution to this linear inequality is this triangular region down here. Okay? Should be pretty simple. It's a little bit long, but not difficult. All right, let's talk about graphing absolute value inequality, or absolute value. And in this case, the first thing we're going to do in all these cases for absolute value is we're going to find the vertex. Remember, the vertex is going to be the highest or lowest point on the V, and I find the x-coordinate by taking the opposite sign there. It's going to be 1, and the y-coordinate is right there. My vertex is at positive 1, 4, so I go 1, 4, right there. Now my slope looks like it's 2/3, and in a sense it is. I'm going to rise 2, run 1, 2, 3. Rise 2, run 1, 2, 3. But remember, with absolute value functions, we have a second slope, and the second slope is going to be 2 over negative 3. You just make the run negative. So I'm going to rise 2, run 1, 2, 3. I'm going to rise 2, run 1, 2, 3. And so what I'll end up with is a V shape coming off of that point we call the vertex. All right, we're going to get a lot of practice with this over the next couple days. I'm going to end the video there. Mr. Laurence signing off. Have a good night, everybody.